Okay, we're going to do some more practice now, all right? Okay, so that's the first one we're going to do. And Brianna Garza's up. Pardon?
We're in the same the two terms.
Well, no. Okay, so now what we're doing is we're just factoring. They're not telling you which method we're using. We're going to have to look at it and identify it. So, Brianna, how you feeling about this? Okay, so what's the first step to factoring? GCF. Do you see a GCF?
Yes.
Okay, so in terms of a number, well, do you have it already, or what do you got? 6 is a common number for both of these. Everyone agree?
Yes.
Okay, so 6, and then what else? X to the 4th power. Good, because this has x 4 factors of x. This has 7 factors of x. So we go with what they have in common, which would be that. And then in parentheses, how many terms are going to go in here? How many pieces will we have inside the parentheses? 2, right? Because there's 2 here, so there will be 2 here. What are they? 4. Okay. Plus 5, because 6 times 5 gives us 30. Third. Okay, good. All right, so that's our first step, right? Now, Brianna, how many terms? 2. And what's the only thing we can factor if we have 2 terms? Subtracted and squared, right? Do we have subtraction and squared? No. So we're done. All right? We're done. You don't need to put prime here because we have factored. We actually have created a multiplication, but we just can't do anything with that. So we box this and we move on. That clear? Mm-hmm. Okay. Let's move on to the next one. All right. Dyson. All right, Dyson. You get this one. 8x cubed plus 12x squared minus 10x. So what are we doing first, Dyson? Okay, which is 4. 2x, okay, 2x. And then a parentheses, enough room for 3 terms, right? So what goes in there, Dyson? 4x squared plus 6x plus minus 5. Okay, good. We all agree with Dyson on that? Okay. What next, Dyson? AC method, because you have 3 terms on this, right? So I'm not sure where you are with this, Dyson. Can you do this mentally, or are you going to need to do something like the AC? So can you do them mentally, like some of them mentally? Yeah. Okay, this one's a little tough though, right? So you might have to like try a couple of different things to get it. So just for the sake of doing the method, let's work through it real quick. Dyson, what would go here if we go and use this method? Negative 20. And then what would go here? 6. Okay, let's see. I said I always like to start out with 1, right? So like 1 and 20. But I need to make one of these negative, don't I? To make a multiply to be negative. Either way I do it. If I put the negative here, this does not add up to be 6. If I put the negative on the 20, it's not going to add up to be 6. Agreed? So what would be the next number that we try? How about 2 times something, right? So 2 times 10? Go with me or no? Yes. Okay, but one of these has to be negative. So would it work? If I make that one negative, that won't work. If I do it the other way around, it won't work, will it? So now you try another number. Does 3 go into 20? No. How about 4? Yes. 4 and 5? 4 and 5? I'd have to make one of these negative, though, to make that negative 20. So again, it doesn't matter which way I do it. If I do the negative here, it adds up to be 1. If I do the negative the other way, it adds up to be negative 1. And yes?
How did we get to minus 20 and 6?
Okay, so at this point, we had 1, 2, 3 terms, right? 3 terms, we use AC method. So we take that number, multiply times that number, that gives us negative 20. And then the middle number is 6, right? And that's what we put in this little cross. Yes?
Did you do the AC method on the second one, not the first one?
You mean not here?
Yeah.
You always have to get the GCF first.
Okay.
Now, it turns out that you could still use the AC method on this, but things are going to go bad because you never pulled an X out. You're probably going to make a mistake within the AC method. So you got to get your GCF first. Okay, so where are we at? We tried 1 and 20, 2 and 10, 4 and 5. Are there any other numbers that we can think of that multiply to be 20? Like numbers that you can just think of? No, right? I mean, we've pretty much exhausted it. Like if we try and go big, we could say 5 and 4, but we've already done that, right? We could say like 10 and 2, but we've already done that. So as soon as you get to a point where these two numbers are like close to one another, and the next number down would appear has already been used, we've exhausted all possibilities. Which means what? What do you think that means?
It's prime.
It's prime. That means we can't factor it. So not, we had, with the 2 terms, we had where we said prime because we couldn't use the difference of squares method. There are times where we can't break this 3 terms down. So at this point, because we can't, we're done. That's as much factoring as we can do. So I'm glad that problem worked out that way because I want us to realize that not everything can be factored.
Is there a way to know that without having to do all this?
There is a way to know that without doing all that, but it's just as much work.
To know
Yeah.
it's prime, though, usually you'd have to do that to figure
Yes.
out the prime.
Yep. If you can't come, well, see, so there's a difference between, like, if you're trying to come up with the numbers, if you're trying it and you can't figure it out, but they really do exist, then, and you call it prime, that would be incorrect. But if the numbers just, you can't ever get the numbers, then it is prime. All right, let's try another one. See who's up here. Devon? Devon? No? Alyssa? All right, Alyssa. Okay, we're working on that one. So what's your first kind of idea here? GCF. All right, I'll give you a second while I write this down to look at it. Wait a minute, did we do this one? This isn't the one we did, right? We did not, right? Okay. Looks familiar. Okay. So, no GCF, so no numbers, right? 15, 26, and 8. Yeah, like 2, well, 2 doesn't go into 15, so 3 wouldn't go into 20, so yeah. How about letters? No. Okay, so there's no GCF here. Everyone with that? Okay, so what next? Count the terms.
So there's 4.
4 means
Do the
group. Yep, you group. All right. Out of the first two now, if you just focus all your attention here, think GCF on these. Now can you pull a GCF? 5, how about letters? X, and that's it, right? Parenthesis, enough room for two terms. 3Z plus 4. Yep. Is everyone on board? Okay, now what? So you're going to pull a 3. So
Wait, no.
how about we do this again? We write down 3Z plus 4. That's what we need, right? And now you try and come up with a number right here that would multiply through to give us back this. 2? 2y. Does everyone see that? So we only have a 3z plus 4. That's all we have, right? So we would need to turn this 3z into a 6yz. So we need a 2y there, and we're going to put a plus in front of it. Plus 2y, so that would give us that. And does this times this give us this? It does, right? So that works. And so now our next line and last, well, hopefully last line is
And it's 5x plus 2y.
5x plus 2y in parentheses.
And then
3z plus 4. And again, it doesn't matter which order you write those in. You could have written this before this one. We're done. Paris. Yeah. First step. Okay, is there a greatest common factor? Is there a number that goes in all those other than 1? No. Okay, is there a letter in all 3? No. All right, so no GCF. Next thing you would do is AC method because you counted 3 terms, right? Okay, so let's do that over here. What are the numbers that are going to go into this little thing here?
So multiply 1 times -15.
Yep, you're taking that 1 times -15, -15, and -2. And now you get to play your game of trying to come up with 2 numbers that do that. So I'm going to give you a minute to try and, unless you have it already. 2 numbers that multiply to be -15 and add up to be -2. -5 and 3. What do y'all think? Yes, -5 and 3. Multiplies to be -15, adds up to be -2. Right? So that step right there is going to take different people a different amount of time to get that. But in this case, it's not prime, so we keep going, right? So now I'm going to rewrite this, and how am I rewriting this?
X squared minus 5x plus 3x minus 8.
So we're using these 2 numbers that we found, right? And we're going to rewrite this middle piece using those 2 numbers. So minus 5x plus 3x, and then minus 15. So just remember, when you go to rewrite it in the AC method, you leave the 2 end pieces alone. And it's all about rewriting that middle piece using those numbers. And then once we're here, Paris, right, we go to grouping. We do that. So Paris, what's the GCF out of the first 2? X will be left with so what do you multiply x by to get x squared? You need x, and then what do you multiply x by to get -5x?
X minus 5.
And that's it, right? And then you need the same thing over here in order for this to work. So then you have to figure out what number would be out there.
What did you just say?
So because of this method, what we do is we get x minus 5 here, and then we say, okay, over here we would also need x minus 5,
Okay.
right? So what number do we need here that would go through and give us back these 2 pieces here? 3. And we'll put a plus in front of it because it's positive 3. And then at that point, you're there. Just need to write the answer correctly. So it should, x plus 3, x minus 5. We're done. All right, I get the feel that most of you got this and just need to practice, all right? So I think at this point I can turn you loose on your homework, and you know, some of these problems get a little uglier, but see how it goes. All right, we're going to move on. Now we're going to start solving equations. Everything we just did was just about factoring, and now we want to solve equations. So here's the idea. We have this very important property in math that I'm about to put on the board here. It's called the zero factor property. I'm going to put a star next to this because it is extremely important, this property. Here's what this property says. It says if you have two things, let's say A times some other thing, B, and if I tell you that they multiply to be 0, so if I'm telling you you've got something times something and it equals 0, then here's what we know. A must be 0 or B must be 0. Any time two things multiply to be 0, one of them has to be 0. So like for example, if I tell you that 4 times x must be 0, then what can you tell me? That x has to be 0, because this means that two things are multiplying to be 0, so one of them has to be 0, right? 4 isn't 0. So x would have to be 0, right? So our solution to this would be x is 0, right? Okay, look at this example. What if I tell you that x times x plus 2 equals 0? So that's multiplication right there, isn't it? What if I tell you something times something equals 0? What can you tell me? Either x is equal to 0, either this one right here is equal to 0, right? Or what? This one is equal to 0, right? That's what the zero factor property is saying. And this is a linear equation. You could solve this for x, couldn't you? If I tell you x plus 2 is 0, subtract 2 on both sides, you get x is negative 2. So you actually have, for this equation, because of the zero factor property, you know that either x has to be 0 or x has to be negative 2 in order for this to be true. Agreed? Okay. What about something like this? Try to go a little bit further here. How about this? If I tell you that x squared minus 4 equals 0, can we use the zero factor property right now? Do we have something times something equals 0? No. We do not. We have something minus something equals 0, right? But can you take this and turn this into something times something? Yes, because this is by itself a difference of squares, right? So we recognize that as two terms. We know that this factors to be x plus 2, x minus 2. We just did that a little while ago. And we know that that must be equal to 0. So you see we have multiplication now? And now we can use the zero factor property. The zero factor property says that If these two multiply to be 0, either this has to be 0 or this has to be 0. So we write down x plus 2 must equal 0, or, and from now on I'm going to put just a line between these, or x minus 2 must be 0. These are the two results. So what does that first equation give us as a solution to this? Negative 2. And what does this equation give us? Positive 2. So we have two possible solutions to that equation. If I take 2 and I square it, I get 4, and I subtract 4, I get 0. But if I take negative 2 and square it, what's negative 2 times negative 2? Still 4, and then minus 4 will have 0. So we get two solutions. Is this making sense? What about this? What if I tell you that x plus 1 times x minus 3 times x plus 5 equals 0? So now I give you not just one multiplication, but three multiplications. The zero factor property still extends to three things multiplied. So if you have two things multiplied equals 0, then one of them has to be 0. If three things multiply to be 0, then one of these three has to be 0. If there were four things, then one of those four things has to be 0. So for this, what I would do is I would say, okay, x plus 1 must be 0, or x minus 3 must be 0, or x plus 5 must be 0. And now I have three separate little equations to solve. And then this one would give us negative 1. This one would give us 3. And this one will give us negative 5. I'm trusting that you can solve those little equations moving the numbers around, right? Is that all right? So would you agree that if it looks like this or like this, it's not too bad to solve this? You just set each one equal to 0? Would you all agree with that? The trouble is we want to solve equations where we're not given this. We're given it expanded out. So we need to factor it out to this and then go, right? Now, the zero factor property can be used incorrectly. Let me show you an example of a big mistake. So careful here. I don't like showing mistakes, but I see it done by students so much that I need to point it out. What if I say x plus 2 times x minus 5 equals 2? Can I, at this point, put x plus 2 must equal 2 or x minus 5 must equal 2?
I think you can do the first one, not the second one.
So I'm saying here that I have two things, right? A times B equals 2, right? Does that mean that A has to be 2 or B has to be 2? Basically what I'm saying is this. If we have two things that multiply to be 2, does that mean that that has to be 2 or that has to be 2? No. Can somebody give me an example of an A and B that would work here that would make this 2, but neither one of them is 2?
Like 4 and 1/2?
Yeah, how about like 4 times a half? Does that equal 2? Does 4 times a half equal 2? It does, right? But neither one of these is 2, right? The only way the zero factor property works is if it's equal to 0. We have to have that. So if this is 0, then look, I don't care. You can spend the rest of your life looking for numbers, but there's no two numbers that you're ever going to be able to multiply and get 0 without one of them being 0. All right? So we just want to be careful as we move ahead that if we're going to use the zero factor property, then this side needs to be 0, not 2 or something else. All right? All right, so we got this zero factor property, and now let's try and solve some equations. Oh, that's not it. Oh, I'm looking at the wrong thing. There we go. we go. We've gone through all the sticks today, so we get to go back to them again. Let me pass around the sign-in sheet. I still need to put a couple of grades in the system. I haven't done that yet, just to let you know I will take care of that. We haven't signed in a while, have we? Seems like we haven't. Let's see, today is the 3rd. We took a test. All right. Okay, there you go. Okay, here we go, here we go, here we go, here we go. Brianna Garza. You ready? See this first one here? 9x squared minus 16 equals 0. Can you use the zero factor property right now? Do you have something times something equals 0? No, you have something minus something equals 0. So you cannot use the zero factor property unless somehow magically you have a way of making this multiplication, which means factoring, right? That's what factoring does. It turns things from this into things being multiplied. So essentially what we're doing, Brianna, is we're just ignoring this and acting like we're doing what we were doing right before this. So when you look at that, what do you see?
9x squared minus 16.
Uh-huh. So how would you factor that? Like GCF first? Is there a GCF? No. Okay. Count your terms. 2. So there's only one thing it could possibly be, hopefully, and that's the difference of squares, right? So this is the bad thing about summer class, is that, in normal class you would have gone home and done your factoring homework and got it all down, and then now you come in here and we do this and you've got the factoring down. You had 10 minutes on a break to figure it all out. So I'll help you. Any idea how this will go?
This is going to be 3x minus 4 or 3x plus 4.
3x minus 4, 3x plus 4. So we have to recognize this as being something squared. 3x squared, and then minus, this has to be something squared, 4 squared. 16 is 4 squared. So this is our a squared minus b squared, and that formula that I gave you is a plus b times a minus b. So this will become 3x plus 4. Brianna, does this make sense?
Yeah.
Okay. So if we can use the formula, then at this point, Brianna, what do we do? This is the new part now. If those two things multiply to be 0, then what do we do? So either this has to be 0, right? Or this has to be 0. So I'm going to write those two things down. Either 3x plus 4 has to be 0, or this one has to be 0. Does that make sense? Sure? And now these equations that we have here that we're left with are linear equations, which are things we should be able to solve at this point. You move your 4 over by subtracting it on both sides and then divide by 3. Here you move the 4 over by adding it on both sides and then divide by 3. So I'm going to trust that you could get from there to the answers. Paris, what's up?
Question on attendance, because you marked the line down both the days that we were here.
Yes.
Were you just counting everybody here for that day? Or
Well, I think I did on one of those days, I did like a handout, something or another. So don't worry about those 2 days. Just sign in for today. Okay, so I subtract 4 here, subtract 4 here. That gives me 3x is negative 4. And then I divide both sides by 3, so I get x is negative 4/3. Right? And then I do the same thing on the other one.
So you want to leave it as negative 4 thirds?
Yes, leave it as negative 4/3. This one will come out to be positive 4/3. So those are our two solutions. In order for this equation to be true, either x has to be negative 4/3 or x has to be positive 4/3. In either case, that equation will be a true equation. Allison? Oh, wait, sorry, Allison. Alyssa. Interesting. You get the next one. I'm going to help you all through these, okay? Won't completely hang you out to dry here. All right, so Alyssa, you see we have an equation, right? That's the big difference between this, what we're doing now, and what we were doing before. Before, it was just an expression. There was no equal sign in there, and you were asked to factor. Now we're being asked to solve this equation. Tell me what x's make this true. The only hope you have is the zero factor property. That's the only hope you have. So right now, do we have something times something equals 0? We don't, right? So if we're going to use the zero factor property, we should probably get 0 on one side of this equation, right? Yeah, so move the other ones over. And you get to choose which way, but I think what we'll do is we'll leave these here and we'll bring these this way. And to do that, we would subtract the 2 and add the 7x on both sides. So I'm going to subtract the 2 under the 5, and I'm going to add the 7x over here because I can't combine it with this because this is x squared. So Alyssa, what would I have on the right side after I do this? On the right side of the equation, what would I have? 0, which is what we wanted, right? So now we've got 0. And then what would we have on the left side, Alyssa? And put it in descending order, highest power of x down. You're adding those, not multiplying. So they're not like terms, so you can't put them together. So you'll just have the 2x squared, right? You'll still just have that. Plus 7x. These two are like terms, so you can put those in. Plus 3. Is everyone clear on that? So we look at the equation to start with. We say, okay, look, this is not an equation we know how to solve. It's got the squared in it. Okay, so it's not linear anymore. So what are we using? We're using the zero factor property. Let's send everything to one side and get it equal to 0. Now we take a look at that, and Alyssa sees that and thinks, when's the class going to be over, right? Are we almost done today? Wow. Right? 1:30?
Yeah.
Pardon?
It's already set to 0.
It is set to 0, but this is not something times something, right? So you got to get it there. So how are you going to get this to something times something?
That thing.
Yeah. Okay. So I think we're talking about the same thing. So you're just going to ignore this, and now you're going to go back to what we did before we took our break. Okay. So you look at that. You say GCF.
They don't have any common numbers.
There's no common, so there's no GCF here, right? Count the terms. 3 terms. 3 terms. AC method. Yep. Okay. So I'm going to do the AC method on the side. I'll do it over here. So Alyssa, what numbers are going to go in this little thing over here?
The top one is 6.
6,
And then 7.
7. Okay. And then you have to come up with 2 numbers. Multiply to be 6, add up to be 7. Take your time.
And then like
1 and 6. Yep, 1 and 6. No, I can put 1 and 6, or I can put 6 and 1, right? And it doesn't matter which way I do it. So I'll put it the way you said it, 1 and 6. Everyone agree? Okay, and then now watch how I do this. I'm going to come over here. I'm going to write 2x squared plus 3, because Alyssa told me that I'm not supposed to touch the ends, right? The middle one is the one that's going to get changed. And Alyssa, what do we change that middle 7x to?
To the 1x,
1x.
or just x, and then with the 1.
You don't need the 1, but let's put it.
Okay, so 1x and then plus 6x.
Plus 6x, perfect. Okay. Now we got 4 terms on the left. The whole idea behind that is to go to grouping now. Group. Just pull an x. Okay, if I pull just an x, Alyssa, what will be left here? 2. And I pulled one of these x's, so 2x plus 1, because I did pull this x. Be careful here, because when you pull that x out, you still have to have something there. So you need to have a plus 1 here to distribute through and get 2 terms. I see the mistake, sometimes people don't put anything there. They're like, oh, I already pulled the x, so I don't need anything. Well, if you multiply this through, you don't get both of these back. You need the plus 1 to create the 2 terms. And then over here, we need it to be the same, right? 2x plus 1. So Alyssa, we're so close here. What goes here to make that go back? Just 3. Put a plus in front of it, because it's actually positive 3. And then don't forget, Alyssa, on this step, we still have this equation, right? So just I'm bringing the equals down as I go. Now this side, x plus 3 in parentheses, and then 2x plus 1 equals 0. And finally now, we've got it to where we can use the zero factor property. We have this times this equals this. Then you set each one of them equal to 0 now. So I'll come over here. I'll put a little bar here. I'm going to go x plus 3 must be 0. And I'll put 2x plus 1 must equal 0. And now you get to solve those little linear equations, moving things around, dividing, whatever you need to do here. Just give you the answers. -3, and this one will be -1/2. There you go. Good job. So what are we saying? What are we saying here? We're saying this equation right here. If you wanted to know what x's to plug in to make it true, these are the 2 x's that'll work. I'm going to check one of them. I'll check this one because it's easier. If I take -3 and replace my x's, let's see what we get. 2 times -3 squared plus 5 equals 2 minus 7 times -3. When I'm done with this, I should have something equal something, and it should make sense. So -3 squared, 9 times 2, 18 plus 5, 23 on this side. Does that equal this side? Okay, 2, now we have to do multiplication first because of order of operations. When we multiply these two together, we have a negative times a negative. We get positive 21, right? So we're taking 2 and we're adding 21, and that gives us 23. So it's true. The other number that you can plug in here to get this to be true is -1/2. I'm not going to do it, but -1/2 squared, then -1/2 right here, they should be equal to the same thing. All right, so the factoring is a very powerful technique that we need in order to solve equations. Well, nonlinear ones that have x squared, x cubed, things like that. Let's do one more, and then we'll call it a day. I think you've been through enough. Pardon? I didn't catch you. What?
The one with the
Fraction?
fraction.
Yeah, let's save that for next class. What I'm going to want you to do tonight for homework is the factoring. The solving equations I don't really want you to mess with. We're going to come back and do more of that next class. I just want to kind of get you, get your feet wet here. Let me see here. Yeah, so there was one there. That next one, I think we'll do that one. We'll be done. Let's see who is going to be the lucky one here. Marcus? Marcus. So we're asked to solve this equation, Marcus. And the reason we know it's an equation is because of the equal sign, right? And can we use the zero factor property to solve this? Do we have something times something equals 0? No. Not yet, right? But we do have equals 0, right? So we don't have to do that first step that we did on the previous problem where we had to move everything over to one side. Like everything's already there. So now you just have to see if you can factor out that left side. So what do you think, Marcus? How are you going to go about factoring?
Number.
There's no number that goes into all of them, okay?
So they all have X.
They all have an X, don't they? Okay, so you want to pull a GCF of X out. I'm with you. What would be left if you pulled that X out?
20X
20X
plus 4X
plus 4X squared, good,
plus 25.
plus 25. And then I'm going to put that in parentheses, and then I'm going to keep this equal 0 here because we actually do have an equation to work with. So Marcus has pulled the X out, which leaves Marcus with 3 terms, right, Marcus?
Yes. You do the AC.
AC method. Now, be extremely careful there. I see you punch on your calculator. Are you ready for the AC method? Do you have your crossy thing here yet? There's something a little tricky here. I only mentioned it one time when we did the AC method, that when you start with the AC method, this thing, we need 3 terms, but it needs to be written in descending order.
Oh, yeah.
Do you see the orders off here?
Yeah.
So if you do AC method right here, it's going to be incorrect, because if you do 20 times 25, it's wrong. Okay? You've got to have this in the proper order. So the next step, I'm going to rearrange this in descending order. Y'all see that? At 4x squared plus 20x plus 25. Now we can go to this. So what number is going to go up top here, Marcus?
100.
100, right? And then the number on the bottom? 20. Okay, so now you're looking for these numbers. So that's kind of a little tricky step there, isn't it? Just be careful with that. So 1 and 100 won't work. 2 and 50. 3, how about 4 and 20? 5 and, what is it? 5 goes in there. Wait, hold on. Why did I put 4 and 20? 4 and 25. Right? Are we going to get it? 10 and 10. Oh, so it's way down here on this list. So 5 and 20, right? 10 and 10. 10 and 10. So now I'm going to go in. Are you okay, Marcus? Okay. So x parentheses.
4x squared
Mm-hmm.
plus 10x plus 25.
There you go. Group it.
4.
And what do you want out of that first 2 there?
That's going to be x parentheses 2x.
Okay, so 2x out. Is that what you said?
Yeah.
Take a 2x out. So you can pull a 2 out of a 4 and pull a 2 out of a 10, and you can pull an x out of both of those. So 2x, and then what's here? Sorry?
2x.
2x
5.
plus 5. I like it.
And then so you can do the same thing on the other side.
Yep, 2x plus 5 on this one. And what goes out front there?
Plus 5.
Plus 5 equals 0. Yeah.
So there's going to be, you still have the x outside, right?
Yep, you still have the x outside, so x.
Parentheses 2x plus 5.
Yeah.
And then 2x
Yeah.
plus 5.
Yep, again, right? It's the same thing twice, isn't it? Equals 0. Now, Marcus, we can use the 0 factor property, right? We have things that multiply to be 0. This times this equals 0. So you set each one of them equal to 0. So I'm going to set x to 0, 2x plus 5 to 0, and then I have to do 2x plus 5 to 0 again, right? But, I mean, I really don't have to do the math. Oh, I forgot equals 0 here. I don't have to do this twice. I mean, I only have to do it once, but I want to just point out it's this, this, and this, right? What about this first one? There's nothing to solve here, right? X is 0, that's the answer. So if X is 0, the original equation is true. And then for this one, just move the 5 over, divide by 2, you get negative 5 halves. Negative 5 over 2. You get the same answer here. So there are only two answers to that equation. The only solutions possible are if you let x be 0, it'll be true, or if you let x be negative 5 halves, it'll be true. Okay, so for your homework tonight, just do the homework section on factoring. So you should get a good mixture of, GCF with grouping, and then AC method, and then they call it binomials. When it's two terms, they call it binomials in the packet. Have a good, 4th of July weekend, right?